Now let's take a look at how we can keep track of time, but much more accurate time, and also alleviate the problem of using the onboard millisecond function, which actually only starts working once the board is powered up. So if I use something called a real-time clock module, something like this one right here from Seed, this will allow me to set the date on the little microcontroller on here, and it's the current date and time. And with the battery, once I add one to here, it will remember that. It's a little clock. And if I go back a year from now and check it, it's actually very reliable. The clock should be fairly accurate within a second or so. But more importantly, it continues to run when the Arduino is not even powered up. So it adds much more accurate time, and it isn't dependent on the Arduino itself or any of the internal timers built in. And today what I decided to work with is this board by Adafruit. It's the data logging shield. Has a bunch of other different capabilities, but we're going to be using the real-time clock, which is actually this little integrated circuit right here that relies on the battery right here. And what's nice about this one is it allows you to prototype on here. It also allows you to write to SD cards and a few other things. It's a pretty neat shield, so let's take a look at how it works. So we'll start off by plugging it into the Arduino. I happen to be using the Arduino Uno right here. And I'll go ahead and connect it to my computer. You can see it's powered up. And let's take a look at the code. I have the product page uploaded already, and what's important for you to know is that it relies on some libraries. And if you scroll down here, you can see there's a link to the real-time clock library. You download that and install it just like any other zip file. I've gone over that many times. I don't need to do it again, but you can see I click on it, I download the zip, and then in the Arduino software, just like any library, I can include that as a zip file. I've already installed it, so I have the code here, and I can show you where it's located. So in examples, if I scroll all the way down here, it's RTClib, and there's two versions for this Adafruit one, and it depends on which type of integrated circuit is running the clock. I happen to know that mine is the 1307, so I'm going to run the DS1307. And here's the code. Let me clean up my desktop a little bit here. And it's fairly easy to implement. Now there's one really cool trick, and it's why I like this one. Setting the time on these can be a bit of a pain in the neck. So if you think about what happens when I want to replace this battery in the future, how do I set the time here? You can do that, but you're going to have to do it through the Arduino, through a different sketch, typically. And what I like about this library is to set the date and the time on the little integrated circuit here. If you look at the code and scroll down to right here, this line, it says RTC.adjust, and then all these different things in here, date, time. And if I uncomment that, check my board is good, my port is good, and I upload it, the first thing this sketch will do is set the date and time on that integrated circuit according to my laptop or any computer that's hooked up to the Arduino. So it's actually pretty cool. It doesn't require you to know the date or time, and it couldn't really be easier to program. Once that's done, I can comment it back out and upload it again, and now it's actually not going to run that part of code. It's going to run the demo code, which in this case is just grabbing the date and time and doing some simple calculations. If I look over here at serial begin, I'll see that I need 57,600. So when I open up the serial monitor, and I'm already set to that, which is great. And here you go. Here's the data I'm getting. It's set the time, the date, and actually it does a quick calculation of since midnight, January 1st, 1970, it's been 17,181 days. So it's really easy to implement, and it's really accurate. And what I really like about it is if you were to, say, have a sensor, maybe you want to keep track of, a type of an alarm or a frost warning or movement in your backyard or something like that. Not only can you have a sensor be triggered by that event, but now you can accurately date and time stamp it.